We've now moved on to the cover crop experiment. This is an experiment funded by AHDB as part of their Soils and Rotations project. And in common with the experiments we've done in the last two previous seasons, we've had an oak cover crop here planted in mid-September, and then we've defoliated it at various times through the growing season. So the first defoliation, the early defoliation, was roughly in mid-March. The later defoliation was in roughly mid-April, and essentially we then had other plots that weren't defoliated, so they went straight into the cultivation before they were defoliated. If we actually look at total dry matter production of this cover crop, it was about 2.2 tonnes, and the nitrogen uptake of the cover crop was about 57 kilograms of nitrogen per hectare, so that's its maximum nitrogen uptake. And that is fairly typical of the dry matter production and nitrogen uptakes of all the cover crops we've seen in this programme as a whole. So we've obviously seen a huge range, but the average will be about that range, 2.2 tonnes and 57 kilograms of nitrogen uptake. One of the things we've discussed before is the carbon-nitrogen ratio of the cover crop residues. Are they likely to release nitrogen as they're ploughed in, or lock nitrogen up as they decompose? So the C/N ratio of this particular oak crop was about 22, which means it's probably not going to do much of either. It's not going to release much nitrogen to the following potato crop. It's not going to lock much nitrogen up. And I think the point here is cover crops, in the context we're using them, aren't green manures. They're not being incorporated to release nitrogen into the other crop. They're there for another purpose. And the other purpose we're particularly interested in is moisture uptake, or taking up water, so it actually makes cultivations easier in the spring. And again, in the presentation, you can see some data where we've measured soil moisture in the surface layers and in the subsoils, where we can actually see where we have a cover crop early defoliated or undefoliated. In the topsoil, there's very little difference in moisture content, but at depth, the cover crop has pulled water out and is significantly drier. And that will have an effect, as you can see, on the soil structure. So in the wetter soils, where the crop was defoliated early, it's much sort of blockier and much less friable. Whereas where we had the cover crop grown up right at the end, it's taken more water out, it's drier, and when it's cultivated, it actually has a much more friable seed bed. And that effect is also seen at depth. So we're having quite a big effect on soil structure as a consequence of growing the cover crop. Now, one of the things we're interested in, then what happens to the growth of the subsequent potato crop. And obviously this is quite an early stage of its growth, but we have got some interesting data on crop emergence. And perhaps counterintuitively, it's where we've have the early defoliated, which is I'm standing sort of just behind me, that emerged about 4 or 5 days earlier than the late defoliated or undefoliated cover crops, which is counter to what we'd expect from soil structure. And we're not quite sure yet why that may have happened. So it may be due to soil moisture, it may just be drier, too dry, where we've had cover crops growing for longer, or it may be due to the amount of organic residues we're putting into the soil. We hope to find this out, again, by perhaps measuring bulk densities a bit later on. The cover crop experiment is part of, it's one of several experiments we do each year as part of the Rotations project, most of which obviously is occurring off-site. And for those of you who came to the AGM in February, we presented some data there, which shows that on average, if you grow a cover crop, you get on average a 2.9 tonne increase in yield. And where we've done the statistics on that difference is significantly different. Where we've looked at amendments, the average increase in yield is about 1.9 tonnes a hectare, and that difference is actually at the moment too small to be significantly different. So if we look at the cover crops, where we've looked at costs of growing a cover crop, basically that 2.9 tonnes increase in yield can cover the costs, the extra costs associated with production. So by the looks of it, growing a cover crop is generally beneficial. Just to finish off, just talk very briefly about some off-site work. Again, it's AHDB funded, and this is a sulphur program. Again, I've shown some data from that experiment, or those experiments at the AGM, where to date we've seen no significant response to sulphur fertilisers on some outside sites. Now, despite COVID, we've actually managed to establish 4 more experiments this year, and again, sort of my thanks go out to the collaborating growers and agronomists. Without that, nothing would be possible. And again, we'll be presenting those data at the AGM next year.